Hi and good morning to everybody. I am Cristian Randieri, and I would like to give you a brief introduction about myself. So first, I am the founder and CEO of an Italian company called Analisys Technologies, committed to research and development, and also committed to innovation. I have a PhD in computer science and telecommunication. Also, I am a computer vision adjunct professor at a campus university. And I collaborate for the NASA postdoctoral program, NPP, as advisor at URSA. Also, I am a certified innovation manager by the Italian Ministry of Economic Development. So let's introduce the topics that I will speak about today. This topic is focused on the prediction of the atmospheric pollutant concentration in both urban and industrial areas. And we know that this is a big issue, and it is of great significance for the decisions making. This topic will consider the possibility of machine learning techniques in order to identify models for atmospheric pollution prediction. It gives the results of short and medium range prediction of the concentration of pollutants that are the ozone, then NMHC, that is hydrocarbons mixture, the nitrogen oxide, and also the combination of nitrogen oxide, which are typical of the photocycle cycle of nitrogen. I will show that the results obtained by the machine learning techniques have a good capacity for modeling the phenomena under investigation as compared with the traditionally used autorecursive prediction models. So the big question that came on my mind a few years ago was, it is possible to use modern machine learning techniques based on soft computing for the prediction of atmospheric pollutants. This was a big issue, because we know that to try to forecast the atmospheric pollution is very, very complex, because there are many nonlinear variables involved on the systems, and the systems that have to be modeled is practically totally nonlinear. So we will see that the traditional method have difficult to try to forecast with a low margin of error. So let's introduce the soft computing concept. Soft computing is a branch of computer science that studies computer systems inspired by biology. It deals with developing artificial intelligence systems with focusing and or architecture similar to those used by humans. Humans are able to modeling uncertainly, starting from some information from external environment. And we know that how we reason in our mind is not focused. By the way, each person can try to think, to try to solve a solution in different way, in different mode. So the soft computing go in contraposition to the standard hard computing, because the hard computing based on the mathematical models does not predict uncertainty and inaccuracy in the computing, processing, and decision phases. So we'll try to use these techniques to try to overcome this standard hard computing problem and issues. So soft computing is an evolved computing model for solving nonlinear problems that involve uncertainty, imprecision, and approximate solution, as I just introduced before. The term soft computing was coined by Dr. Lofty-Zade in the early 1965 with the introduction of fuzzy sets, just the the word fuzzy, let you imagine that something is not focused. So let's go ahead. The advent of soft computing into the computing world was marked by research in machine learning, probabilistic reasoning, artificial neural network, fuzzy logic, and also the genetic algorithms. The methodology is so defined as soft because the precision is nuanced and the logic of the instrument is not rigid, but is elastic. So let's try to introduce the components of the soft computing. First, let's do a brief introduction of neural networks. The artificial neural networks are parallel calculation architecture whose structure is based on the human brain. We can take a look at the picture and we will see that neural network models is essentially composed from neuron and synapse. Each node is a neuron. Each conjunction line between two nodes is a synapse. Each node transfers the information to the other nodes only if the synapse is activated by a function. This is the way how our brain is synced. And the neural networks is a translation of this biology concept in mathematical models. So a neural network is suitably trained using a set of examples that they can learn. For example, they can extract the link between the input data and the corresponding output data. Also, the neural networks can thus be used to solve a number of problems of classification in which a priori knowledge of the model is not needed. For example, the forecast of pollution, atmospheric pollution. So the second technique is the fuzzy logic. Fuzzy logic resembles the human decision-making methodology. It deals with the vague and imprecise information, contains the multiple logical values, and these values are the truth values of a variable of a problem between 0 and 1. Also, this concept was introduced by Dr. Zade on the 1965, based on the fuzzy set theory. How it works in briefly. Okay, I try to give you a little example. The concept of cold, warm, and hot for a human is not strictly confined to something is cold, warm, and hot, but it is unfocused. It is fuzzy because each person have thermal perception different from each other. So we have a particular indecision zone where we switch from cold to warm, for example, or from warm to hot, where this zone can be different from each person because the human have different perceptions. So this is basically how the fuzzy logic works. By the way, that each discrimination between different concepts is not focused, but have a particular function that we'll try to describe the uncertainty. Okay, last method of of the soft computing are the genetic algorithms. That genetic algorithm is a method for solving both constrained and unconstrained optimization problems based on a natural selection process that mimics biological evolution. Briefly, genetic algorithms are commonly used to generate high-quality solution to optimization and search problem by relying on biological inspired operators such as mutation, crossover, and selection. Use properly these terms and techniques that are translated on mathematical concept where an algorithms can evolve based on those concepts. And typically, a typical basilar example is to find minimum point of a generic analytic function, for example. By this, if we have different sample of this function, we can apply genetic algorithms in order to find the minimum, for example. Okay, so at the end, the soft computing concept makes the best use of the three disciplines that I briefly try to introduce. So the ability to learn from examples of neural networks, the ability to model and control complex and uncertain from fuzzy logic systems, and the ability to optimize problems of genetic algorithms. So essentially, the soft computing put in match two concepts: the functional approximation randomized search and the approximate reasoning. Each of one have down different methodology that can support to reach the purpose. So I like to match the Lofty-Zadeh quote, where he say that one of the reasons humans have better control abilities than current machine is that human can make decisions based on unimprecise linguistic information. And this is very interesting because this is essentially a very small concept that briefly resume the large concept of machine learning, because machine learning is focused on on the fact that we try to modelize nonlinear systems with nonlinear models. So the combination of different things put together can origin the hybrid artificial intelligence. Essentially, hybrid systems combine two or more individual technology, fuzzy logic, neural networks, and also genetic algorithms, for example, to build other intelligent systems in order to overcome the constraints and the limitation of every single technology. So hybrid systems represent the boundary between human thought and artificial intelligence. I want to give you an example. For example, the Neuro-Fuzzy networks, just the name, let's keep in mind neural network and fuzzy, and something of mixing between the two methodology. Okay, the Neuro-Fuzzy networks, it's very useful because exploit the capabilities of neural networks combined with fuzzy logic, where it is not possible to use fuzzy logic in all those application files in which experts are not already able to formulate the results. Because we know that we will see, and I will introduce the fuzzy logic too. This methodology, the fuzzy logic, okay, at the end, I give you few results based on rules, but these rules, if are not well interpreted by specific experts, they have not too much value. By fuzzy logic, we can overcome this by translating this rule in mathematical models and also in data. So at the end, the winning match is to combine human teams with artificial intelligence for do the origin of hybrid artificial intelligence. So by refining this rule and concept and models, we can try to add performance to the models that we want to analyze and to perform. Okay, so after this brief introduction of different concepts and methods regarding the machine learning and soft computing, I want to speak about a real case study. Is the prediction of atmospheric pollutant concentration in a specific area with an high density of industrial plants. More specifically, the industrial area under investigation is in the province of Syracuse in Italy, where I'm from. More precisely, the Priolo Melilla Augusta area, which feature as a high density of petrochemical industries. The area is also monitored by an atmospheric pollutant monitoring network located over a number of strategic points. The data considered in this paper was supplied by the SIPA, is Industrial Consortium for Environmental Protection, and refers to time span of 3 months. In this map, you can see the specific region that is in Sicily, in the Syracuse province, and you can see that each of these dark region is a very complex refinery plants, and you can see that this area is very concentrated. Okay. Our study is based to try to forecasting the pollution, starting from the consideration that have origin from the photolytic cyclic of nitrogen. Because among the numerous ways of studying pollution, we have chosen the model the pollutants produced by alteration of the so-called photolytic cycle of nitrogen oxidation. So, due to the presence of reactive hydrocarbons released into the atmosphere, which favor the formation of the nitrogen oxide and ozone. In this picture, you have 2 cycles, the cycle A and the cycle B, where the cycle A is the standard photolytic cycle of nitrogen, in which one is the natural, where there is no presence of hydrocarbons. This will be perturbed by the presence of the hydrocarbons that we can see in the B representation. Try to false the cycle and do origin the different kind of pollutant in different concentration. So we'll take focus to try to forecast the pollutants originated by the second representation of this photolytic cycle of nitrogen. Okay, you can think that there are different issues. The first is the complexity of the model that we would like to forecast. So modeling atmospheric pollution phenomena is a complex task and on account of the influence of a number of external variables. For example, the temperature, humidity, wind speed, and also direction, and so on. And the presence of time variance and nonlinearity effects, which make the traditional identification techniques not particularly appropriate. So, the literature provides several approaches to the modeling of atmospheric pollution time series data. The most popular are parametric identification methods that are based on stochastic models of the ARMAX, autoregressive moving average with exogenous input type. Briefly, the general structure of ARMAX models is of the following type. We have a specific equation where inside we have the output function with the input function, and all is combined with the white noise and also the other vector parameters. I don't want to say here to go in depth to explain how it works, these models, but I want just to give you a briefly overview. So we will show that the best results obtained are those relating to the use of the second-order models without explicit inputs. For example, the autoregression AR models. So we will see that in the next discussion, we will talk only about the AR models that, as I told you before, it better match the modelization of the air pollution. Okay, so our things is how to addressing the problem with soft computing and machine learning tools. Essentially, 2 kinds of neural networks are represented on this topic, the multilayer perceptron and fuzzy neural networks, plus a mixed prediction model based on the combination of two prediction models, autoregressive and multilayer perceptron, in order to improve the results obtained with the previous ones. Multilayer perceptions are widely used nowadays, so it's not necessary to recall their features here. So let's go to introduce the new concept of the fuzzy neural networks. Fuzzy neural networks are special neural networks in which the weights of the connection represent the parameters of a set of fuzzy rules, like if pressure is high, then volume is low, where pressure and volume are variables, and height and low are fuzzy set. Fuzzy set means that are not fixed number, but some specific function that may vary. So fuzzy set are linguistic terms that are expressed in an exact mathematical way by using the concept of membership function, which represent the degree of truth of an assertion. For example, pressure is height in a range between 0 and 1. A membership function can have the several shapes, the most common being Gaussian, trapezoidal, triangular, and also sigmoidal. Okay, let's speak about the data preparation and validation. This is a big issue because we have different data, and it's very important to apply the preprocessing phase in order to identify non-valid data to malfunction of the recording equipment. Non-valid data is automatically marked by the recording station, which replaces the true value with a predefined flex, for example, a negative value. So on the data streaming, we will find values of concentration, of pollutant concentration that can be negative. If they are negative, it means that this value should be not considered. So when this occurs, the corresponding samples was not considered by our study, our algorithms, for the preparation of the learning pattern. For example, string of input and corresponding output data. So we decided to cut all the patterns, even if only one pollutant product was minus. Okay, the time series considered were the concentration of the ozone, the NMHC, the nitrogen oxide, and the combination of nitrogen oxide. Okay, so let's talk about the samples that we keep in consideration in order to modelize the different systems. To identify 1 hour prediction models, we used 315 over total of 700 selected patterns, while the overall dataset was considered for the testing phase. To identify the 24 hours prediction models, 40 patterns obtained from the original time series by subsampling at the intervals of 24 hours were used, while the overall dataset consisting of 80 samples was considered for the testing phase. Okay, so let's go to show the results. The first results is show the comparison between the real and simulated data with 1 hour and 24 hour AR model, the autoregressive model. That is the standard model widely used to try to forecast the pollution. So we can see that in this graph, we have the representation where the real data are with the dotted line and the simulated data with the solid line. We can see that we have an error that is not too much bad, but the problem that we can find is when a peak occurs. When a peak occurs, for example, in this graph, in the NMHC concentration, we see that the algorithm have little problem to try to identify the peak, taking account that the peak of concentration is worse for the population, because this can put in alarms and all the devices that are suited to the pollutant concentration, and so it can stop the industry activity for save the population. Okay, so in this first graph, we have essentially a comparison of the 1 hour models between the different pollutant concentration. And in the last graph, we have the prediction at the 24-hour models, briefly reported only for the ozone concentration. Okay, let's go ahead. So, in this slide, I show you what is the structure of the multilayer perceptron neural model used for the ozone concentration prediction. Essentially, we have a black box where the input are the different concentration sample of ozone and MHC, the NO2, sorry, and NOx at different time. So the sample at time k, the sample at time k minus 2, and so on. And the output is the concentration of the ozone at time k plus 1, next time. So it should be noted that since there are no particular limitation in the complexity of the networks, unlike what happens for Neuro-Fuzzy networks, it is possible to consider more inputs. And also, I want to remark that this complexity can grow up in function of the pollutants. And what is comfortable is that now with a big calculus resource, we can try to expand these models with each year has much more variables as inputs. Okay, so this is the same results obtained with neural networks for the prediction at 1 hour and at 24 hours. We can see the graph, and for the different concentration, generally we can take a look of the errors, and we see that error is much more smooth. What is important always is to observe the peak. What is important is that by neural networks, we are able to reduce drastically the peak error of the pollution forecast. And also for each pollutant concentration, for the different pollutant ozone, NMHC, the NO2, NOx, and also is the same for the 24-hour models. So let's show you the models regarding the Neuro-Fuzzy used for the ozone concentration prediction. As I told you before, this model is much more complex to be simulated over computers, and so we needed to choose less inputs in order to improve the speed of the modelization. So always is a black box with that have as inputs the different concentration, different time of the different pollution, and give as outputs the forecast of the ozone concentration. Obviously, this model is particular to the ozone, but with the small changes of the outputs, it can be applied to the other pollutants. For each input of the model, free Gaussian membership function were used, and the products as the interference method was adopted. So let's see the results, we see that the results are not so good as the multilayer perceptron, but it's remarkable that the error is comfortable with the AR models. Also is important to see how it follows the peaks. Generally, we say that is in the middle between the AR model and the neural networks models. But what is much important for the Neuro-Fuzzy networks is that this model is capable of extract rules, because considering that the winner-take-all competitive learning methods applied, the distribution of obtained rules led to a selection of only 40 rules of the total 6,561. As introduced before, each rules is a combination of the different pollution. For example, a typical rule is if the ozone concentration time key is low, medium, high, and the concentration of the O3 is at the time k -1 is low, medium, etc. The results, so the prediction of the O3 at time k +1 is. So by this rule dataset, we can go much more in depth inside the number. We have not only number, but we have a set of specific rule that can be studied through the specific person that works, for example, in chemistry, to try to understand hidden dynamics of how the concentration can be influenced by the combination of the considered input pollutant concentration. So the last models that we used was a mixed models, a mix between an AR model and a multilayer perceptron models, where the first model has the same structure as the model already presented. The second, instead, has the forecast of the pollutant concentration of the previous models. So the AR model is the first model that we used. These models give the forecast of the ozone, and this is used as input to the multilayer perceptron models. By this, we will show that we can combine the properties of these two technologies in order to improve the results. In other words, this structure is an attempt to recover the prediction error of the first model. So let's go. Let's go to see the results. The results is very interesting because effectively we can find that the error is very smoothly and it works well as the peak occurrence, and the combination between these two models without add too much complexity to the global models is very interesting and performance. Okay, so let's go briefly to try to give an analysis of the results. We have to take in account that public authorities are often not interested in knowing the exact value taken by the concentration of a given pollutant, but whether the concentration will exceed a prefixed threshold. This threshold is very important because if a pollutant overcomes this threshold, this is an alarm for the population. It means that the concentration is too high, and the government or something for it should take action. So two indexes indicated as Q1, Q2 respectively were defined with the aim of comparing the capacity of the models to foresee when the concentration of a given pollutant, for example, the ozone, will overcome a prefixed threshold. Q1 was defined with the purpose of measuring the perceptance of correctly identified samples which exceed a prefixed concentration threshold, and Q2 represent the percentage of badly identified samples. For example, samples whose value does not really exceed a prefixed concentration threshold, but wrongly indicated by the prediction model as doing so. The result concerning the bot index, as a general remark, it can be observed that when the threshold is set at height values, for example, a concentration of 90 micrograms of for meter cube of ozone, which is interesting for public health protection purpose, the neural models, and in particular the multilayer perceptron, work better than the other models that has been considered in these topics. So it should be remarked that the usefulness of fuzzy neural networks mainly lies in their capacity to extract knowledge, which represent a transparent form of modeling from which the analyst can obtain useful indicators regarding the phenomena being investigated that he can integrate with his own personal knowledge. So the mixing of all these techniques is a powerful instrument to try to understand better the hidden dynamics of the that are on the basis of the forecast of the pollutant concentration. So let's talk about the future developments of these techniques and of the mixture of these techniques. The main idea is very interesting, is to create a smart pollution monitoring station which has a built-in machine learning algorithm. So I try to imagine a industrial cabin with inside different instruments that actually measure the different concentration of pollutant. If we try to implement this kind of algorithms directly inside this machine, we can have two kinds of information. The first is the actual concentration and the historic concentration of each pollutant. The second, much more precious, is the forecast of these pollutions at a few hours or at 24 hours. This is very good idea in order to give a very nice support decision making for the authority. So being able to modulate the production of industrial air pollutants starting from the forecast of their atmospheric concentration, we can protect both the community and the industrial production, which in this case would not be subject to any abrupt interruption in production. So, as you know, we have always in contraposition the safety of population and the industrial production. Normally, these are in contraposition, but we try to find the better solution for try to keep both interesting at the same levels, by way to keep the population safety and to let the industry have a standard production. So this is our idea, and how we try that all these systems can help for try to solve this big issue and problem, with the scope to give a very nice support on decision-making methods for the government and other institutions. So thank you for your attention. In this slide, I let you my contacts. If you have any idea, if you have some question on something that you like, you can reach me with this contacts list. Okay, so I stop my presentation and let's go with the question time. If you have any questions, you can ask me and I will try to give you the answer. Thank you very much. Okay. Okay, this is a very interesting question. Is there are some countries or region who adopted the AI for modeling pollution data already? If yes, which ones do so the best? Okay, actually, to be honest, I don't know exactly if there are countries that adopt this tech massively. But one thing is sure. Sorry, I began to study this dynamics and this solution almost 20 years ago, where I was a student because, to be honest, this argument was one of my first publication that I did before to have my degree, because it starts with like a little study for a professor, but the professor was so impressed that decided to let publicate this study. Today, in 20 years, we did a lot of improvements about these algorithms. The problem is that to try to make these instruments a reality for the institution is not so easy. You have to take in account that the trust for the machine learning and or in generally for the artificial intelligence is just starting now in Europe. All the community is moving in this direction, but you know, a lot of people are at the moment only curious. I believe that government of a different country can massively try to start to adopt these techniques. And also, I hope that someone would like to invest on the application of this methodology. But the winning idea is to implement these algorithms inside the measurement instruments, as I showed you in the last slide. This is very important because to give a real-time forecast of pollution is a very, very interesting topic. Okay. If there are other questions, we have 1 or 2 minutes. I believe that this technology will improve shortly because it's very important to push in this direction. And regarding the scientific activity, there are a lot of papers that talk about this because this is a very big issue. Okay,